Okay, good morning, guys. Welcome to Cycle 2. I hope that all of you are as motivated as I am to start this cycle and continue with our math class. Um, we are going to be continuing with the topic of shaping our faith in God, and I have two because this is the second unit that we're doing with that same idea. And we're basically just gonna continue from where we left off last 2 weeks. All right. So now, before we go ahead and do that, I want to start and I want to do something different this cycle. I want to be able to start each of our classes with a word of prayer. So I am going to be doing that, guys, and I can't see you, but hopefully you can join me and be reverent as I lead you guys in a word of prayer. All right. So let's pray. Heavenly Father, thank you for allowing each one of these unique students, Lord, to be able to join my session today, Lord. May you open their hearts, Lord, and may you open their minds so that they are willing to learn the math concept that I have prepared for them today, Lord, but as well, through the math, be able to see your fingerprints in everything, Lord, in everything that we do and everything that we learn. Dear God, I ask that you guide them, Lord, through this math session, Lord, and through all of the classes that they will be having today, Lord, that they may be as motivated and as willing to learn in all that they do in this day. I ask this in your son's precious name. Amen. Okay, guys. So, as I said, we're starting with this idea of but we're continuing with the idea of shaping our faith in God. And my deep hope for this unit did change a little bit because we are moving into some different concepts in math. So my deep hope says that we may be God worshippers and image reflectors, and that didn't really change as we nurture our faith through courageously designing quadrilateral constructions, 2D and 3D shapes, while exploring our image bearer responsibility. So you have an idea of what it is that we want to cover in this unit when it comes to our math concepts as well. I did give you guys an evaluation form that I wanted you guys to fill out. And what I noticed in that form is that some of you were not able to relate or see yourselves practicing the through lines and see yourselves practicing the habits of learning. So, being very direct in this case, the biblical through lines that I would want you guys to see and to participate in this unit in this 6 weeks that we're going to be talking about shaping our faith is God worshippers and image reflectors. And the habit of learning that we're going to be practicing is courageous designing, which basically means we're going to be doing a lot of hands-on thing, a lot of graphing, a lot of drawing, a lot of construction is awaiting us in this unit. And when I talk about their framework, this week we're just going to be talking about creation. And I want to see if you guys can clearly understand how our math topic is a part of creation. And as we go along in this 6 weeks, so 6 weeks is a lot. It's going to take us way into December doing this topic. We're going to talk about fall, redemption, and restoration. So now, the creation topic for this week, what I want you guys to understand. When we do shaping our faith in God, the math idea that is in that topic is shapes. Now, what math idea or math topic or math unit talks about shapes? In this case, geometry. So basically, what we're going to be learning is continue talking about geometry and everything that has to do with constructions. And if you guys had seen the message that I posted in Google Classroom, this week you need graph sheet and next week you need a math set, because we are gonna continue graphing and we're gonna start with constructions. All right. Now, when we talk about this idea of geometry, we talk about shapes. And if I were to tell you guys the history of geometry and who came up with the shapes, a square, a triangle, a circle, and we did touch a little bit about that when we talked about trigonometry. And I said that a lot of you want to go back to the topic of trigonometry, Sakatawa, sine, cosine, and tangent. That was something that I saw in your celebrations of learning that a lot of you want to go back to. When we did that topic, we talked about the father of trigonometry and we talked about Thales. And you guys had to do a report on him or any of them. And he was the father of trigonometry, the one that started all of these mathematical concepts with triangles. But the idea that we want to see is that if we talk about the circle, so many math persons had debates and battles of what a circle is, what is the definition of a circle, how many degrees does a circle have. When if we go to the Bible, in Isaiah 40:22, the Bible said that the earth is in a shape of a circle. And there was so many debates. If you guys remember your religion studies or your social studies from primary school, when you talked about Christopher Columbus and all of that time when they thought that the earth was flat. So if you sailed to the end of one side, you would drop off of the earth because they thought that it was a flat shape. And in the Bible, if they would just have looked in the Bible said that the God created the earth in the shape of a circle. And we see that geometry is found in so many things that is a part of creation. When we did symmetry, and a lot of you chose symmetry to be your best work when you had to find symmetrical creations and the flowers and the animals and everything in creation that has symmetry. So many things in creation have to do with math. And today we are going to talk about another form of transformation. And hopefully you guys can continue having that same idea that math is found in creation. So now our essential questions: how are geometric properties used to help solve real world issues? That's a big question. Real world issues. What are real world problems that geometry can solve? And how can geometry be used to solve problems about real world situations, spatial relationships, and logical reasoning? And throughout the 6 weeks, we're going to be targeting these two questions. So now, I have one question for you guys. And I want you guys to type it in the chat. We're going to do the waterfall. You type it, you hold it, and when I count to three, everybody's going to send their answers. What are, and listen to the question carefully, what are the three types of transformation that we did last cycle? What were the transformations that we did? And we did three of them. And your last project that you guys worked on for week 9 talked about all three of them. What were these three transformations that we did in cycle 1? Because that implies our fourth transformation that we're going to be having um, for this week. So think about it, type them, and when I count to three, you guys are going to send it, right? Okay, at the count of three, I want to see all 23 persons sending an answer in the chat. And it's a very simple question, right? What are the three types of transformation that we did? At the count of three, one, two, three. Okay, let's see. Rotation, reflection, translation, translation, rotation, reflection. Okay, very good, guys. Reflection, rotation, translation. These were the three things that we did in the last week. So now what we're going to be doing today in today's lesson, we're going to talk about, sorry, not translation, it should be dilation. Let me fix this right now. We're going to talk about dilation. So the last transformation is dilation, and I want us to figure out what dilation is. And I took this prayer from First Chronicles in the Bible, and I want you guys to read through it, and I want you guys to find the only math word that you find in this verse. What is the math word that you guys can see in this phrase?
Territory.
Territory would be more like social science work.
Enlargement. Enlargement.
Enlarge, enlarge. The prayer of Jabez, oh, that you would bless me indeed and enlarge my territory, that your hand would be with me and you would keep me from evil, that I may not cause pain. The math word that I want you guys to identify here is enlarge. So now dilation has to do with enlarging and with reducing. So now, how am I gonna do this? If I were to give you guys a triangle, do you remember when we did reflection, rotation, translation, and I would give you guys a triangle and you had to either flip it, you had to turn it, or you had to slide it. Dilation now is that you're gonna take this shape and you're either gonna make it bigger or you're gonna make it smaller. All right. So that is the idea of dilation that we want to do for this week. So now you guys are going to define dilation. You're going to describe an enlargement and describe a reduction. And you are going to construct these enlargements and dilations. Very good, Eimer. A dilation is an enlargement or is a reduction. So now if we take a look at what dilation is, We're not changing the shape. We're not gonna be making one side bigger or one side different than the original shape. It is just, it's like when you guys are on your phone and they send you a picture and you zoom it. That is what we're going to be doing. We want to zoom in and we want to zoom out of the picture, and we have to construct that on a graph sheet. So now, a dilation that creates an image, a larger image, is when we call an enlargement, and when you create a smaller image, it is called a reduction. But how do we go about doing this? For dilation, it is very important that you understand the concept of a scalar factor. Now, a scalar factor is one number, and that one number will determine if you are going to enlarge or if you are going to reduce. So now, if they give you a scalar factor that is 2, and they give you a scalar factor that is half, you need to be able to tell me, when I see the 2, am I going to enlarge or am I going to reduce? And when I see the half, am I going to reduce or am I going to enlarge? And you need to be able to determine that based on this scalar factor that the question gives you. So now, if the scalar factor is greater than 1, your image enlarge. So if you have, for example, 2, 3, 4, 5, any number that is bigger than 1, you are going to enlarge your image. And if you have a scalar factor that is between 0 and 1, what is between 0 and 1? Well, any decimal and any fraction that is between 0 and 1, when that is your scalar factor, you now have a reduction. So, for example, let's say that I give you half, I give you 3/4, I give you 2/5, I give you 1/6, I give you 5/9. All of these will lead to a reduction that will occur because all of these fall between 0 and 1. And the same thing could apply if they give you 0.25, 0.9, 0.45, 0.125. All of these will lead to a reduction because they fall between 0 and 1, right? But we have to be careful. Let's say that they give you 2.5. Is that an enlargement or is that a reduction?
Enlargement.
It's an enlargement. Very good. Because it is bigger than 1. Even though it is a decimal, it's 2.5, and 2.5 is bigger than 1. So, dilation in the coordinate plane. Let's talk about a dilation with a scale factor of 2. By looking at the scale factor 2, and when we talk about the scale factor is represented with the letter K. So they will tell you that K is equal to 2, K is equal to 3.5, K is equal um, to half. K represents what a scale factor is. So when you see K is equal to this, okay, I know that K is a scale factor. So now when we talk about this dilation scale factor of 2, how do I take my original image, which is ABC, and I get A1, B1, C1, which is my enlarged image? And if you take a look at what I have there at the bottom, we multiply by 2. So if they give you a scale factor of 2, then you times by 2. If they give you a scale factor of 3/4, then you multiply by 3/4. If they give you that K is 0.35, then you multiply by 0.35. And you do that to the X and you do that to the Y. And you get your new points. And the same thing will occur if you have a scale factor that leads to a reduction. My original image is ABCD, and my new image is A1, B1, C1, D1. And because they gave me a scale factor of half, I now need to multiply -2 by half, 4 by half, 4 by half, 4 by half, 2 by half, 2 by -2, -4 by half, and -2 by half. And every single x and every single y of each point will need to be multiplied by a half. Anybody has any questions?
Clear.
Yes.
It's clear, guys? Give me 1 second. I need to quickly do something. Okay, guys. Sorry about that. So now, continuing. Dilation and similarities. We have to understand that when we describe a dilation, be it an enlargement or be it a reduction, we don't use the word congruent, because congruent means exactly the same. Congruent. We do not use that word. Congruent means that I have one triangle, I have another triangle exactly the same. Did not flip it, did not turn it, and that is what we did when we talked about translation. We had congruent shapes because they were exactly the same. We only slide it somewhere else. But when we are talking about dilation, we use the word similar, because they are in the same form but they're of a different size. So we have to have that idea in mind. When we want to describe a dilation, they are similar shapes, they are not congruent shapes. And with that in mind, we're gonna work with some of the questions that I have in the worksheet. Before I do that, everybody has everything clear that I explained right now. You guys understood. No, you cannot use the word symmetrical. The word symmetrical would be used for a reflection. So reflection would be symmetrical. Right? So then those are keywords. Any other question? No questions?
Yes.
Um, so now, the first activity that I have in Google Classroom is this one. Okay. This one is a more direct worksheet, and we're gonna be working with some of the sections right now. And then tomorrow and the rest of the week, we're gonna be working with the rest of the worksheet and with the other one. So now this worksheet is basically direct questioning. It's if you understood the concepts that were explained for today's class. This one is a fill in the blank. We're gonna do that right now. And this one is state, is it a reduction or enlargement? One word answers. And this one we're gonna do right now as well. Section 3, Section 4, and Section 5. we will be working with tomorrow because it entails calculating. How can I calculate the scale factor of something? And that's why I have k is equal to a blank line, because you have to do the calculation to determine
Are we
it.
gonna use a graph sheet?
We're not going to be using graph sheets for this worksheet, but we are going to be using for the second worksheet. Let me show you guys that one. Yeah. Okay. So now this is the second worksheet, worksheet number 2, learning activity 2, which is constructing dilations. And in this one, yes, you would need to graph. So this has section 1. This section 1 needs to be done on a graph sheet on its own. And then section 2, you can, if you print out this page, you can do it here. If not, you need to do it on a graph sheet. I think that it will give exact on a graph sheet. It has, if you do it half half, you can do this one at the top and then this one at the bottom in one graph sheet. But you would need at least 2 graph sheets for this activity, and we will be doing this on Wednesday. So for Wednesday, if you don't have graph sheet today or tomorrow, for Wednesday, I would expect you guys to have that on a graph sheet. Yes? So let us continue. Okay, fill in the blanks, and we're gonna do this in the chat. In math, the word dilate means to blank or blank. What are these 2 words?
Is that part of the work or is it just like practice?
No, this is part of the worksheet. These are the same questions that I just showed right now. Okay. The word dilate means to enlarge or reduce. Very good. Eimer has the correct words. Jerome, very good. David, very good. We want to make our sentences grammatically correct. So we write enlarge and reduce. You do not want to put enlargement and reduction, because then the sentence would not make sense. In math, the word dilate means to enlarge or reduce or enlarge, whichever order is correct, but using the correct form of the word, right? Any questions with this one? No questions?
No, miss.
If a scale factor is less than 1, then your figure gets read carefully. If a scale factor is less than 1, keyword less than 1. If a scale factor is less than 1, then your figure gets reduced with the D at the back, reduced, or you could use the word smaller. Either of those words can work. Reduced with the D to make your sentence grammatically correct, or smaller. Right? So now, if a scale factor is greater than 1, if a scale factor is greater than 1, then automatically you should know the answer for this one. Then your figure gets enlarged with a D. Enlarged. And I see very good. Eimer, Jerome, Edmond, very good. The word enlarged or bigger, whichever one works. And this is section 1 of learning activity 1. These were the fill in the blanks that I showed a little while ago, right? So now let's talk about the second section. And this one is very easy. We're going to be doing the waterfall. I want everybody to participate. You are either going to put reduction or enlargement in the chat, right? Looking at the scale factor of 3, type your answer. When I count to 3, everybody's going to send your answer. And when you're going to do these for these 4 questions, I want everybody to be participating, right? So that they see that everybody understands. So if you have a scale factor of 3, is it a reduction or is it an enlargement that will happen for your dilation? 1, 2, 3. Okay. Starting from Edmond was the first one that sent an answer. Very good. Enlargement, enlargement. Very good. Enlargement. Excellent work. Next question. If you are given a scale factor of 1 over 3, 1/3, is it a reduction or is it an enlargement? Starting from Herbie. Very good. Reduction, reduction. Very good. Excellent work, everybody. Next one. 5/4. Is it a reduction or is it an enlargement? 5/4. 5/4. Reduction or enlargement? Let's see. I will start from, I think it was Jerome. Reduction, 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 reduction. What if I told you that all of you sent the incorrect answer? 5/4 is.
Yo creo que es enlargement porque el 5 está arriba, miss. Está más alto. Ya iba a mandar enlargement, pero como no estoy muy sure, no lo mando.
Everybody sent the
By the
wrong.
plano,
Everybody sent the wrong answer.
Rápido marcar enlargement.
5/4 is an improper fraction. If I put 5/4, that's 1 and 1/4. That's 1.25. 5/4 is an enlargement. So the answer for this one should be enlargement. Everybody saw that? Everybody saw their mistake?
Sí, miss.
Okay, good. And then the last one. What would this one be? Okay, so let's see. Dylan was the first one. Reduction, 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 creo. You have to be sure and say, Miss, 100% sure this is my answer. Reduction. Very good, guys. Reduction. 0.93 is less than 1. All right, it's a decimal, less than 1. Okay. Today's exit slip has been posted in Google Classroom. So I want you guys to go to Google Classroom. And I want you guys to do the exit slip that I have there posted. Right here, November 1st exit slip. And then it should look like this. I have one for each one of you posted there. And we have time to do it. It's 11:18. And this is what it looks like. There you go. So now what I want you guys to do is I want you guys to grab three little faces of these little emojis and I want you to drag it into the circle. And I want you to tell me what were three reactions that you had today. Um, did you feel bored? Did you feel I don't know, love? Did you like the class? Are you confused? Did you have an aha wow moment? Choose three of them, put them in little circles, and then you write. Doesn't have to be a sentence, just a little phrase. I felt blank. I understood this. I did not understand that. Anything that you reacted to in today's class. All right? And you guys can do that. It's posted in Google Classroom, right?
Mandrake edinis.
You cannot edit it?
Niyo, miss. Niyo. Niyo, mo ito.
Hmm, are you sure? Okay, then do something. Go to file and then you make a copy of the entire presentation and then you just add it as an attachment. I'm not sure why you cannot edit it. So let me repeat that. Go to file and make a copy of the entire presentation.
Please mind it, God.
Repeat again.
My one is working.
Your one is working. I'm not sure. Maybe it's your device. I'm not sure. Because I did make a copy for each one of you to be edited. But if you cannot, then just go ahead and make a copy and then you just attach that copy. All right. So you can go ahead and choose any of the little faces that you want there and you drag it in the little circle and then you just tell me why did you have that reaction. All right. 4 more minutes, guys. We leave at 11:25, right?
Already handed in my miss.
Okay. If you have handed in your one, then you guys can leave the class. I'll just keep the class open for 2 more minutes. But if you're finished,
My
you're free to
miss.
leave. Bye, guys.
Bye, miss.
Bye.
Sir, maayos pati view niya.
Repeat again, Emma.
Sir, maayos pati view, miss. No puedo marcar nada.
You can't.
Miss, ni yo no puedo hacer copy nada, miss, para que lo puedas hacer.
Okay. Let me send it.
Miss, maybe it's their device. Maybe they're working on the phone or tablet.
Okay, let
Yes,
me.
you're on the phone, that's why.
Okay, maybe that's why. If your phone doesn't have Google Slides, I don't think you will be able to edit it. I will send you guys the link in the chat. Change anyone. You have to make a copy though. All right? I will add you as an editor in my original one, but don't edit it. Just make a copy. It should allow you to do it. But if not, I would appreciate if you could just write it down. Write down the three sentences and then you take a picture of your three sentences if you cannot edit it after this. Right?
But
That
I done before.
yes, if you're finished, you can leave.
I mean,
Bye. See, I can see you guys are here. Try to make a copy and see if it would work.
Miss, I have done it, miss.
Okay, thank you very much. You can leave.
Bye, miss.
Bye.
Finished, miss.
Okay, thank you. You can leave. Okay, guys, I'll close the class because I know that I'm not sure if you have another class, but it's past 11:25. If you cannot do it still, Russell, write it on a paper. Write three sentences on a paper, and then you can take a picture of that and you send it to me. All right?
Okay, miss.
Okay. Bye, guys.
okay,
Bye, miss.